This is lab number 4, from Dreamcatcher ME5100 University courseware, captured on video. We are going to learn about AES 256 encryption and decryption techniques, and use it to implement a secure, wireless communication between the sensor node and gateway. To get the most out of this course, you should view this video along with the lab sheet. Please refer to the description section for the lab sheet download link. You may want to pause this video to read the lab sheet first, before proceeding with the video stream. This is your sensor node, which is the Texas Instrument Launchpad Development Kit. In Task 1, we are going to set up the sensor node, to acquire temperature sensor data using the built-in temperature sensor. Then in Task 2, we are going to learn about AES 256 encryption techniques. In Task 3, we are going to encrypt the temperature sensor data with AES 256 encryption. Finally, in Task 4, we will set up the Bluetooth wireless link to the gateway, which is the Raspberry Pi. The sensor node will send the encrypted temperature data to the gateway through the Bluetooth wireless link. The gateway will then decrypt the encrypted temperature sensor data received from the sensor node. Task 1. Reading temperature sensor data. Before starting Task 1, ensure you have copied the provided Lab 4 files, which are embedded in the lab sheet to your PC. Then, extract the files out from the zip archive. Connect the micro USB cable to the sensor node board. Connect the other end of the micro USB cable to your PC. Start the Code Composer Studio and create a new CCS project. Name the project as Lab 4, Task 1, and click the Finish button. Next, copy the provided C code files into the created CCS project folder. You are given the basic C code to make the sensor node to acquire the temperature data from its built-in temperature sensor. Understand the C code files carefully before proceed to next step. This video will skip all the CCS project settings that you will need to set. Please refer to the lab sheet for details of the settings before proceed to build the project. If the settings are not done correctly, the project build will not be successful. Let's build the project. After the build complete, load the program to the sensor node board. When the program finishes loading, the sensor node board LCD will display the temperature sensor reading of its surrounding. Task 2. Advanced Encryption Standard, also known as AES in short. We are going to use the sensor board to perform a basic encryption of a given plaintext and encryption key. Run Device Manager from your Windows Start menu. Note down your COM port number for MSP application UART1. For this PC, the COM port number is 5. You will need this when you are connecting to the sensor node using PuTTY software. Close the Device Manager window, and go back to your CCS window. Create a new CCS project, and name it Lab 4, Task 2. The following will be skip in video. After the creation of the project, copy all the provided C codes files for Task 2 into the CCS project folder. Please refer to Task 1 on how to do it. Set all the necessary project settings. Please refer to the lab sheet for details of the settings before proceed to build the project. If the settings are not done correctly, the project build will not be successful. The C code provided has an added verify_AES256 function. The function has the encryption key and plaintext hard-coded into it. Understand the function to learn how AES256 is being implemented in this lab. You can even experiment with different values after this task. Run your PuTTY software. Set up a serial connection to connect to the sensor node through COM5. Minimize the PuTTY window for now. Build the project and load the program to the sensor board. While the program is loading to the sensor board, bring back the PuTTY window. When the program finishes loading, the sensor board will perform a basic AES256 encryption, and the output will be displayed in the PuTTY window. This is how the output at the PuTTY window will look like. The encryption took 23,904 clock cycles to run, and it's equivalent to around 1.494 milliseconds. Next, proceed to answer the questions in the lab sheet for Task 2. Task 3. Protecting sensor data with AES encryption. In this task, we are going to learn how to implement Aes encryption in the sensor node to encrypt the temperature sensor data. Create a new CCS project and name it Lab 4, Task 3. The following will be skipped in this video. After the creation of the project, copy all the provided C codes files for Task 3 into the CCS project folder. Please refer to Task 1 on how to do it. Set all the necessary project settings. Please refer to the lab sheet for details of the settings before proceed to build the project. If the settings are not done correctly, the project build will not be successful. The AES functions are implemented in the temp sensor function. You can find the codes for this function in the temp sensor mode.c file. The AES encryption method used in Task 2 are being used to encrypt the temperature data. Understand how the implementation in C code before proceed. Build the project, and load the program to the sensor board. While the program is loading to the sensor board, bring back the PuTTY window. When the program finishes loading, the sensor board will encrypt the temperature sensor data continuously, and the output will be displayed in the PuTTY window. The sensor board is now encrypting every temperature sensor data it acquires. This is how the output at the PuTTY window will look like. Close the PuTTY window after verifying your results. Disconnect your sensor node USB cable from your PC to power down the sensor node. Let's proceed to Task 4. Task 4. Protecting the communication between the sensor node and gateway with AES encryption. In this task, we will implement a secure wireless communication between the sensor node and gateway using AES256 encryption and decryption. Take out the Bluetooth module from the anti-static box next to the sensor node. Connect the Bluetooth module to the sensor node. Connect the micro USB power supply connected to the gateway without switching on the power. Connect your PC monitor to the gateway using HDMI cable. Connect your USB keyboard to the gateway. Connect your USB mouse to the gateway. Connect the other end of the sensor node USB cable to the PC to power it up. Create a new CCS project and name it as Lab 4, Task 4. The following will be skipped in this video. After the creation of the project, copy all the provided C codes files for Task 4 into the CCS project folder. Please refer to Task 1 on how to do it. Set all the necessary project settings. Please refer to the lab sheet for details of the settings before proceed to build the project. If the settings are not done correctly, the project build will not be successful. The temp sensor function is now modified to encrypt the temperature data with a new encryption key and send it to the gateway through Bluetooth. Build the project. Run your PuTTY software and set up a serial connection to connect to the sensor node through COM5. You see that the program from Task 3 is still running. Now, load the program to the sensor node. When the program finishes loading, the sensor node will start to acquire the temperature sensor data, encrypt them with Aes 256, and send the encrypted data to the gateway through Bluetooth wireless communication link. While the program is running, power up the gateway. In the Gateway Linux system, start a new terminal. Turn on the built-in Bluetooth, and run a search of nearby Bluetooth devices to look for the sensor node. Wait for HC06 device. That is the sensor node. Type exit and hit enter button when you see HC06 appears. Connect the gateway to the sensor node using Bluetooth communication link. You will need the MAC address of HC06 for the connection command. Once sensor node is connected, leave the terminal window running and start a new terminal. Copy the Python codes provided by the lab sheet, and paste them into the gateway. There are two sets of Python codes to receive the encrypted sensor data from sensor node. One with no decryption, and one with decryption. At the gateway, you are provided with a Python script that receive the encrypted temperature data, and decrypt them using the same encryption key that the sensor node is using. You can experiment with different encryption key after this task. Run the Python code without decryption. As you can see from the terminal that the received data is gibberish as the data is not decrypted. Start another terminal to run the Python code with decryption. Oops. You will need to stop the previous Python code from running as the code is occupying the Bluetooth link. Rerun the Python code again. As you can see now, the Python code is now receiving the temperature sensor data from the sensor node, and correctly decrypted the data. This is how the output looks like in the Gateway Linux terminal. You have now successfully set up a secure communication link between the sensor node and the gateway, using the Aes Encryption method. Thank you for watching, and have a good day.